Alright, so far we have one of the members unknown. There are, if you remember, there's 1, 2, 3, 4, 5 different members that we have to solve for. Depending on where you start from, you can call each member a different name. You can say this one is DC, this one is CD. You can call this one BC or CB. You can call this one BD or DB. AD, DA, etc. In this case, we have solved for member AB. So the first unknown that we have is member AB. And if you go back to the drawing that I just redrew up here, so member AB is actually this guy right here. So we figured out that there is no forces acting on that member. Okay, so moving on, so we did the calculations at joint A. So I'm going to just box this off so we don't get it confused with anything else. We're going to be looking at the calculations at joint C. So I'm going to just write it right below here. So calculations at joint C. I'm going to screw it up so you guys can see it. So if you look at joint C, there is a 1,000 pound force acting down on it. There is member CB, meaning from C to B, since we're starting at joint C for all these. And then we have another force that is CD. I'm going to just assume that it's going to be in tension. Again, we're always just assuming that until the math tells us otherwise. So we have this. Let's try to figure out an unknown. So for example, I want to figure out CD. Since I know that one of my knowns is actually in the y direction, I'm going to do the sum of the forces in the y direction to figure out the unknown. And we know that should be equal to 0. Now again, for the y-axis, down means negative, up means positive, so we are going to be labeling this as a negative 1,000, so that's the force going down. And we also have this component in the y direction, so CD in the y direction. We will need the angle for this, which if you look from the diagram, the angle is actually going to be 45 degrees for that. So if you go back to the diagram, you can see that this is 45 degrees. Alright, so finally we have CD, sine of that angle. I'm going to call this negative again because if you guys notice, this is going to be going in the downwards direction. So CD, sine of the angle, which is 45 degrees, and then we're going to have another minus 1,000 pounds of force is equal to 0. So let me zoom this in just a little more. Okay, so if we solve this, we're going to be solving for CD. In this case, add 1,000 on both sides and divide by negative sine of 45. So we get CD is equal to negative 1,000 divided by sine of 45. The negative, I moved it to the top because it was in front of the sine 45, because it really doesn't matter. We get CD is going to be equal to negative 1414.21 pounds of force. Again, so far we solved for the forces in the y direction. We solved member CD in this case, which was the force in the y direction. We did this one first for a reason. This is actually in the y direction. This is one of the actual guys that we know, so we want to do that one first. Now I want to do some of the forces in the x direction to figure out what other unknown I can get, which in this case would be CB. So I'm going to do it all over again. I'm going to just separate this to be able to do the math for the other component. Again, this is still joint C. We're going to do some of the forces in the x direction equal to 0. If you look at the drawing, it's going to be negative CB, because remember, to the left means negative for the x components. So negative CB. And then we're going to be subtracting, because again, it's still going to the left in this case. Oh, wait, I totally forgot something. So for CD, I wrote down that this is negative 1414.21. The negative actually means that this is going to be in compression. Almost forgot that. That's actually pretty important. So the fact that it's in compression, it means that it's going to be not going away from the joint. So I'm going to go back and label the arrow. This should be going towards the joint, so it should be in compression. Now that changes the direction of my forces in the x direction, because now we have negative CB, but we're going to have actually positive CD cosine of that angle. So plus CD multiplied by the cosine of 45 degrees equals 0. We already know CD though. We figured it out. It was negative 1414.21, so let's just plug that in there. So it's going to be negative CB minus, or actually plus, the 1414.21 cosine of 45 degrees equals 0. You're probably wondering, why did I not use a negative here if the CD is supposed to be negative? Well, the negative for the CD has to do with the direction, whether it's going to be in compression or tension. In this case, since we already switched the arrow, we accounted for the negative sign. So we don't need to do that here. So once you guys switch the arrow, you really don't have to worry about the negative sign anymore. If it's still going to the left, then it's going to be a negative. If it's going to the right, it's going to be a positive. So that's why we have that. So simplify that, we get calculator work. Solve that, we get CB is negative 1414.21 multiplied by the cosine of 45 degrees. And that actually comes out to be a nice number, 1,000 pounds. And since it's a positive number, this is going to be 1,000 pounds in tension. So this member is actually being stretched out in the truss. Let me label it over here. Okay, so if we go back to the original picture, we already have some of our unknowns, right? So we have, we solved for, let's see. So we solved for AB, and we just solved for CD. Again, CD is this member right here. We also just solved for member CB, so from C to B, which is this member right here. All we need to do is just these two guys, and then we're done. So anywhere you want to do the calculations is fine. I like to box stuff off so I don't confuse myself about the work from one problem to the other. So again, I like to do stuff starting with the least amount of forces. So if you start from there, you should be fine. Let's see. Oh, cool. You know what? Even better. I also realized that I forgot to label AD. We had already solved for AD, the calculations at joint A, which is kind of good news because I don't have to do that work again. So AD, we figured out that it was negative 2,000 in compression. So this right here means that we already solved for AD, which is this guy right there. So the calculations at joint A gave us two members. So it was member AD, which I forgot to label, and member AB. And then the calculations at joint C gave us two other members. It gave us CB and CD. So all we have to do now is figure out just one more guy. And you can go ahead and just do the calculations at joint D. You can do the calculations at joint B. It's just a matter of choice. It doesn't matter which one you guys do. You guys know all of the unknowns you need already anyways. So it's just a matter of choice. I'm going to go ahead and do calculations at joint D just because of the fact that it looks like there's a little bit less members there. So I can probably use that. But you could have easily chosen B and then gotten the same answer from that. So I'm going to use this space to figure out the last bit. So this will be the calculations at joint D. So if you look at joint D, so we have this joint, and then there's a 45-degree angle going that way, which is member DC, and we found out already that DC is going to be in compression, right? So it's the negative 1414.21 in compression, so that guy is going to be going towards the joint. So just be careful when you guys have your labels. If it was compression, make sure you make it go towards the joint. If it was tension, make it go away from the joint. BD, we had already, let's see, BD, no, that's the one that we're solving for. So that one we're going to assume that it's going to be in tension. Sorry, I was getting you confused with the other guy. There is an angle of elevation of 45 degrees here. Same thing on the other side. And then there is a 2,000 pound force, which happens to be member AD, which is in compression. For right now, I'm just gonna label it as AD, and then write that in as 2,000. So that one we actually know. I put the known value of 2,000 there. This one we actually know as well. DC is actually 1414.21 pounds of force. So there we go. We know this guy. Oh, I forgot to label it. This is going to be DC. So member DC, which we had already figured out, it's that. Member AD, which we had already figured out, is that. We just got to figure this guy out. So without further ado, let's do it real quick. So we have sum of the forces in the x direction equal to 0. We're going to have in the x direction the 2,000 pound force, which was AD, so it's going to be positive because it's going to the right. We're going to subtract member BD, so this guy, multiplied by the cosine. Oh, and by the way, this is actually another 45-degree angle as well. If you look from the drawing, it's given to be 45 degrees. So minus BD cosine, because we want the x component, so it's going to be the cosine of 45. And then we're going to subtract, again, because the arrow is going to the left, so we're going to subtract this guy, which is going to be DC. But we know DC, right? So DC times the cosine of this angle, so it's going to be the 1414.21 multiplied by cosine of 45 degrees, and then set that equal to 0. If we solve that or simplify that, we get that this actually becomes a nice number. So we get 2,000 minus BD cosine of 45, and then it's going to be minus 1,000 equals 0. So we get negative BD cosine of 45. Once we solve that, is equal to 1,000. Or actually, when we subtract 1,000, so it's going to be equal to negative 1,000. When we divide by negative cosine of 45 on both sides, so negative cosine of 45, negative cosine of 45, we get on the side that member BD is equal to, again, same as the other one, 1414.21 positive, so therefore it's going to be in tension. So I hope this video was some sort of use for someone. And again, if you guys, hopefully you guys paused and went back to whatever you didn't understand to clarify some information for you. So all we got to do now is figure out, hey, wait, we solved this one already, so bam, we are officially done. All of the member forces are solved for.